we're restricted by the form factor, so basically a small device and our finger and our thumbs for typing in as the only interaction styles that we have. So it's just a little bit different and constrained compared to a desktop application or a web application. So obviously got visual components, plenty of them available to us in the three different environments. We're mainly interested in lists, where we spend a lot of time scrolling and looking at things, and then occasionally a little bit of sort of text entry. So sophisticated manipulation of the data we're actually looking at on a small device is challenging, but it's also fairly rare in the applications that we use on a daily basis. But navigation is obviously important. So all platforms have the same form of navigation. Typically you authenticate and enter the app at some place, and then you navigate around by drilling down and then coming back up again. In our data model, so the Slack style model, there were spaces, channel messages, and so on. And that's true in most apps that we use today. Lots and lots of lists, the infinite scroll, the doom scrolling, selecting something we like, having a quick look at it, going back to the list, carrying on scrolling. So the navigation is important. Swipe actions, we've seen how we're doing this on 3 different platforms. With something we want to get rid of, we just swipe it. In some cases, in apps, you don't have to. That's a primary action. Just swiping it gets rid of it. We did the action where you swipe it to introduce a new visual element that we click on with our finger to actually make it to confirm that we actually want to get rid of it. Threads and asynchronous execution, regardless of what platform we're using, we need to actually have the ability to start off new pieces of execution that are not going to tie up the user interface thread. So we can still be doing things in the app whilst other things are processing to the side, depending on the platform. In iOS, the thread is called a task. In React Native, because it's based on Node, we can't create our own thread, but we can sprinkle some syntactic sugar on our code to say this piece of code, please run it for us in a thread, although we don't create it ourselves. So asynchronous execution or creating a thread in order to be able to run a background task. All mobile app platforms have that capability. And the prime, as we've seen in our assignments 3, 6, and 9, the prime reason for doing that is to make a network call. So the thing that we have on our phone is a display of data that is held elsewhere, remotely on the server. Networking calls are inherently slow, especially over a cellular network. So we don't want that to tie up the user interface thread as we're going ahead and fetching our data. And another thing that's common in terms of the way we structure the code internally doesn't affect what the user sees because they're unaware of this, to do with state variables. So we have in different environments, we have different ways of responding to something, a piece of data changing. But the mechanisms are different, but the concepts are the same. We want to have our framework be listening to pieces of data that when they change, we can automatically get a change in the thing we're seeing on the screen. So doing that through models, through view models, they're built-in concepts in some platforms, not in others. So it's a built-in concept in Android. It's a concept that we can easily create in Swift because they have observable data. We can construct a view model from that. In React Native, we can use contexts to create our view model. The concepts are the same, and again, having the ability to respond, to react to changes in the data using the model view controller pattern that's been around for donkey's years. Another thing to so when we're contrasting the platforms is testing. How easy was it to test in other environments? How easy was it to get feedback on how much code we were covering? So the three different testing environments are quite different. There are things that we might like or dislike about them, um, but all of them can when we were doing Android, we weren't actually checking code coverage. We did when we did Kotlin in outside the Android Studio environment because that was built in. The fact that code coverage is not built into Android Studio, personally, I find that's a little bit ridiculous in today's age. But it does have a testing framework, and in all cases, we need to obviously make sure we're testing the application that we know it's passing our tests. But if we know it's passing our tests, the app is only as good as our tests. If our tests are sloppy, then there's a really good chance our app will be as well. So in terms of the three, this is somewhere that you have to make your own sort of decision on, and you will have been making judgments on it as we've gone through it. So what did we like and dislike about each environment? None of them are perfect. All of them have good things about them. All of them have slightly strange things about them. Um, I like the programming style of Swift UI, declarative programming. I like that. What I don't like about developing natively for iOS is how slow the testing is. Really, really painfully slow. Um, but if you had that declarative programming style, which is fairly similar to the way we program in JSX in React Native, but had really, really fast testing, the pendulum might swing back towards native iOS development. But again, nothing's perfect. But you've had a very quick introduction to all three, and so now you can actually have a legitimate opinion. You can discuss with someone and say, well, this thing I like about Kotlin and Android, this thing I don't, and so on. And just be aware that the different you are aware of the differences between the three environments. So if you're interested, if you've sort of got interested in app development and you're thinking, well, where can we sort of go next with this? Well, a good thing to do would be to investigate additional other cross-platform environments. So React Native is great, especially if you have experience using React for web development, because it's JavaScript, stroke TypeScript, most commonly used language in the world. But as you've seen in the applications that we produce, they're very quick to put together. They're it's very easy to test them. But the look and feel of them, even though it's using native components, is slightly different, especially on the Android environment compared to if we were developing it using CodeLoad and Android Studio. So investigating other environments, ones that are coming up and getting very popular. Flutter is definitely the one that's coming along that is most popular. Investigate that. So that is um, it doesn't use native components. So what it does, you investigate this in your own time, but what it actually does is it has its own components that it makes work on the two different platforms. Flutter is also you can write a Flutter app that will run on desktop, on mobile, and in a browser. And the way they do that is that they have a whole ecosystem that you use their components rather than using native components, either directly in Kotlin and Swift UI or indirectly using React Native. So it's a very different approach. It's proving to be a very popular one. So if you were interested in doing a little bit of further work, that might be something to investigate. Okay, and that pretty much wraps us up. So obviously we've got assignment 9 is due tomorrow. If you run, obviously we've got the regular office hours this afternoon. To use the rest of the lecture slot to work on that. Any questions, come along to office hours later on. There are a couple of just two or three outstanding sort of regrading things for me to look at today. We'll get those out of the way before the end of the week, and then once assignment 9 is submitted, that will get graded very quickly. If there are any problems with submissions that don't work or crash and burn in the autograder, watch out for me sending you a message. We might need to get you on a Zoom over the weekend just to sort those out. But otherwise, I think everything's pretty much tidied away. Any questions? Come along and ask them in office hours. Actually, whilst we're here, anybody got any questions? Burning issues on assignment 9 or just generally? All good. All right. So if I don't see you in office hours today, good luck. Grades will be out soon. And any questions that pop up afterwards, you've got questions about, how would you do something beyond what we've looked at in class? Don't hesitate to pop me an email. Happy to talk about those things. Okay. See you in office hours. Otherwise, good luck once the grades come out, and enjoy your break after you've submitted assignment 9. See you soon.